Welcome to Diwakar Physics. So in this video we'll discuss about electromagnetic induction for class 12 ISC and CBSE. Okay, so let us start. The first question is the phenomenon in which an EMF is induced in a coil due to the change in the current in the same coil is mutual induction, self-induction, magnetic induction, none of this. So the answer is self-induction. Okay, so whenever there is change in the current in a coil, then there is the back EMF is induced. So that is called self-induction. Okay, so next question is north pole of a bar magnet is moved towards a metal ring. Okay, the direction of induced current in the ring when viewed from opposite side of the ring is anti-clockwise, clockwise, no current is induced, none of this. Okay, so when magnet is moved towards a coil, then what happens? There is a change in magnetic flux. So there is a, suppose this is the coil, okay, and the magnet is moved like this. Okay, suppose this is a north pole. Then when north pole is moved towards the coil, then due to the change in flux, magnetic flux, so there is induced EMF, and due to induced EMF current will be set up, so induced current. Now the question is, what is the direction of induced current? So for this, so Lentz's law can use. Now when magnet is brought towards the coil, then the electric current is set up here, and this current will oppose the cause. So what is the cause here? So approaching north pole. Okay, so to repel this north pole, so current should be induced such a way that here this face of the coil should have north pole, because it has to oppose or repel this north pole. Okay, so that's why this side north pole, but when viewed from opposite side, now you have to view from this side. Now this side, you can say north pole is formed, then this side obviously south pole will be induced. Now when you view from this side, then here south pole will be induced, and for forming the south pole, then you can remember this clock rule, that when current flows in the clockwise direction, then south pole is induced. So as you are viewing from this side, opposite side, magnet is coming from this side, so here south pole is induced. So to induce south pole, so current should be in the clockwise direction. So that's why the option is clockwise. Okay, and if question comes, if it is viewed from the same side where magnet is approaching, then north pole is approaching, then it should be repelled, the north pole in. And for the north, you have to learn, that is like this, you can remember, anti-clockwise. So for north, you write N like this and put the arrows, anti-clockwise. Then answer would be anti-clockwise if you view from the same side. But if you view from the other side, then it is south pole, so it is clockwise direction. Okay, so this is according to Lentz's law. Okay, so we'll go to the next question. Now your circuit is given with a capacitor and resistor connected with the DC source. So as you know, the DC source is blocked by DC is blocked by the capacitor, so ammeter will not read anything. So the question is, the reading of the ammeter in the following circuit is equal to V by root over R square plus X square, 0 ampere, V by R, and none of this. So here actually this formula is cannot be applied. This is for AC, and so it is 0 ampere because this capacitor blocks DC. So no current will flow through ammeter. Okay. So next question is, so this option is correct. Now next question is, predict the direction of induced current in the metal rings A and B lying on the same plane where current I in the wire is increasing continuously. Now here wire is there and two metal rings are kept. Okay, then current is increasing this side. So will there be induced EMF on A and B? So answer is yes. Okay, because current is increasing, magnetic field is increasing here, and magnetic field is increasing, that means there is change in flux, area is same. So consider this first. Okay, so now when current flows this way, then magnetic field is downwards with the right hand thumb rule. So magnetic field here across A is downwards, okay, into the plane of paper. Now that is increasing downwards, and here EMF will be set up, current will be set up such that it will oppose the cause. So what is the cause? Increasing magnetic field in the downward direction. So that means due to this, magnetic field should be in the upward direction because it is increasing in the downward direction. So that's why the magnetic field should be in the upward direction. Now if magnetic field is in upward direction here, then what will be the direction of current? So again you can follow that clock rule. For example, this is the coil. Okay, so here magnetic field, it should oppose the magnetic field, and magnetic field should be in the upward direction. Okay, upward direction. And if it is coming out of this plane, then this must be north pole. Okay, so because magnetic field is coming up, so from this face it is coming out, so this must be the upper face should be north and lower one south. So that means this should be north, as you are viewing it is north. And so for north, what is the direction of current? So just we have discussed above, so it is anti-clockwise. So that means in the first coil it will be anti-clockwise. So same way you can decide for this. So this is just opposite. If you hold this wire with right hand this way, which current is in this direction, that is the right hand, right hand thumb rule. Okay, so you can hold it like this, then this side of the wire magnetic field is downwards, but you see in this side magnetic field is in upward direction. So same way you will get it clockwise. So the second option is coming right. So A anti-clockwise and B clockwise. This is the opposite direction. Okay, so that way you can solve. Okay, we'll move to the next question. A metallic rod CD rests on a thick metallic wire PQRS, okay, with arms PQ and RS parallel to each other at a distance L is equal to 50 centimeter. So this is 50 centimeter, and a uniform magnetic field B 0.2 Tesla acts perpendicular to the plane of this paper, pointing inwards. Okay, this way, pointing inwards. The rod is now made to slide towards right with a constant velocity of 6 meter per second. This side. So this rod is moved this way. So then question first is the EMF induced between two ends of the rod CD. Okay, so this is based on the motional EMF. So the formula is EMF is equal to BLV. Okay, so you can put the values. B is 0.2 Tesla, SI unit is there. Length is 50 centimeters, so you convert this into meter, and velocity is 6. Okay, then you solve this. So 0.6 volt. So 0.6 volt EMF is induced. So this option is correct. Next question is the direction of current on the rod is C to D, D to C. Direction cannot be determined, none of this. Okay, so here current is induced because of change in flux. Why flux is changing? B is uniform, but area is changing. Okay, because this rod is moved towards right. So then you can use Fleming's right hand rule. So you are finding the direction of current. So direction of current I. So I is used for representing current, and I is there in the spelling of right. Okay, then use right hand rule. So when you have to find the direction of current, then Fleming's left hand rule you have to use. Fleming's right hand rule you have to use, because I is there in the spelling of right. Now when you have to find the direction of force, then F is there in the spelling of left. Then you will use Fleming's left hand rule. So here you are finding the direction of current I, and I is there in the spelling of right. So then use right hand rule. Okay, then how to use right hand rule? So this forefinger will represent the direction of magnetic field, this one current, and this one force. So here you are finding the direction of current. So you set these two, field and force, keeping them perpendicular. Then the direction of magnetic field is downwards, and you see the rod is taken towards right. So keeping the forefinger down, then do it like this. Then you see. So you can clearly see that force is in this direction, magnetic field downwards. Then this current is showing D to C. So current will flow D to C, C to Q, like this. So here you have to write only D to C. Okay, so this is the way to find the direction of current. And next is if the thickness of PQRS is reduced, then induced EMF increases, induced current increases. True or false? Now you see this is a good conductor, so current will flow here. So if you reduce the thickness, means we are increasing the resistance. Okay, so thickness is reduced, that means thinner wire will have more resistance, then this portion will have higher resistance, then current will be reduced. Okay, current will be reduced. So here answer will be false, because here it is given induced current increases. So answer is false. Okay, so let us go to the next question. A coil has a self-inductance of 0.05 Henry. The magnitude of EMF induced in it when the current flowing through it is changing at the rate of 100 ampere per second is 15 volt, 5 volt, 10 volt and 100 volt. So which formula you have to use here? This is the question of self-inductance. Self-inductance is given, L is given, EMF you have to find, and this is current is changing at the rate of 100 ampere per second. So this is di by dt. Okay, so di by dt. Then what you will find? So EMF equals to L di by dt. So this formula you can use. So we need only magnitude, so no need of putting minus, just calculate the values. So what is L? 0.05 Henry. Okay, so SI unit. di by dt, it is 100 ampere per second, so that means 5 volt. So that's why answer is 5 volt. So this is the formula based question. Okay, next is the SI unit of mutual inductance is Henry. Then choose the correct relation. 1 Henry, can you express ohm per second, or 1 Henry is equal to ohm second, or 1 Henry is equal to 1 second per ohm? None of this. So that means you have to express Henry in terms of ohm. So that is what they are asking. Now this is the question of mutual inductance. So what formula is there? So EMF is equal to M di by dt for mutual inductance. Okay, so just we need units, so no need to put sign here. So then what is E? This is V. M di means current by time, so ampere by second. Then M will be equal to volt second by ampere, and volt by ampere is ohm, so ohm second. So V R is equal to V by I, volt by ampere, that is resistance, so that is ohm. So that means unit of mutual inductance can be related with ohm second. So that means this ohm second is correct. So this is correct. Next question is the magnetic flux through a coil perpendicular to the plane is varying according to the relation phi is equal to this Weber. Then induced EMF, magnitude of induced EMF will be how much? At 2 t is equal to 2 seconds. So that you have to find. So here we know from Faraday's law EMF is equal to minus n d phi by dt. Okay, then if the coil has single turn as it is given here, and magnitude if you take, then you can get d phi by dt. So you will get the magnitude by the formula d phi by dt, and as phi is expressed in terms of time, then you will differentiate here. Then you just have to differentiate. So you differentiate. So differentiation of these terms, sum and difference, so you can differentiate separately. And which formula you can use? x to the power n, differentiation of x to the power n with respect to x, because variable is x, and x n minus 1. This formula you can use, but here the variable is t and we are differentiating with respect to t only. Then this 5 will remain, this 5 is constant, so 5 will remain here. Then t to the power 3 minus 1, here 3 will write, and x to the power n minus 1 plus 4, then 2 will be here, t to the power 2 minus 1 plus 2 t to the power 1 minus 1, and this 5 is separately written as a constant term, so it is 0. Differentiation of constant term is 0. Then 15 t square plus 8t plus 2. So this is the flux, EMF, and EMF also depending on time. So when time is 2 seconds, then EMF will be 15 into 2 square plus 8 into 2 plus 2. So 60 plus 16 plus 2. So 78 volt. So that means the EMF induced here is 78 volt. So which option is correct? Now you can see 78 volt is correct. And the next question is, the induced current at t is equal to 2 seconds if the resistance of the coil is 39 ohm, then how much current? So current will be equal to EMF by R. So 78 divided by 39. So 2 ampere current flows. So 2 ampere is the option. So this is the option. Okay. So we'll go to next question. A circular coil of area 300 centimeter square and 25 tons rotates about its vertical diameter with an angular speed of 40 per second in a uniform magnetic field of magnitude 0.05 Tesla. The maximum voltage induced is 15 volt, 0.15, 1.5 and 2 volt. So here also, so the maximum EMF induced for the rotating coil is EMF is NBA omega. Okay, so this is the formula. So how many tons are there? 25 tons. You can see 25 tons. Then what is the magnetic field? 0.05 Tesla. Tesla is also SI unit. Now area is 300 centimeter square. This is 300 centimeter square. Then what you can do to change 100 into 100, and omega is 40 SI unit. So you solve this, you will get 1 point, let's see, so this will give you 15, 0.15 into 10, so 1.5 volt. So this way we can select 1.5 volt. So this is the answer. So coil, when it rotates, the magnetic field produces current, EMF. EMF is induced and current starts flowing. Okay, next question is electromagnetic damping can be achieved with the following current. So this is AD current. This is the application of AD current. Okay. Next question, self-inductance of a long solenoid does not depend on number of turns. It depends on number of turns, area of cross section of the coil, so it also depends on area, permeability of core material, so it will depend on that also. So it is depending on all the factors given. So that means does not depend on, so none of this. So none of this you can take. So self-inductance depends on number of turns, area of the cross section of the coil, solenoid, and permeability of the core material. Next question is mutual inductance of two coils is maximum in the following orientation of the coil. So they are kept perpendicular to each other, then so it cannot be maximum. Okay, so flux produced in the primary will not be linked with the secondary. So that's why this will be false. And when it will be maximum? When, so suppose one coil, there is another coil totally inside the first coil. Okay, so then only it is maximum. So here it is minimum. So answer is false. Next question is, if the current in the primary circuit of a pair of coils changes from 5 ampere to 1 ampere in 0.02 seconds, calculate the induced EMF. If mutual inductance is 0.05 Henry. So then this is the question of mutual induction in the coils where change in current is found in the primary coil. Then which formula you will apply to find the EMF in case of mutual induction? So you will use this formula, EMF is equal to minus M di by dt. Then what is the value of M here? So the value of M is 0.5. Okay, 0.5 di by dt. So how much current is changing here? 5 ampere to 1 ampere. So then 1 minus 5. Ampere is in SI unit. So current is in SI unit with ampere. And time is 0.02 seconds. 0.02 seconds. Then minus 0.5 into minus 4 by 0.02. Then 5 into 4 1, 2, 0. 100 volt. So we are getting 100 volt. Then you can mark this option as correct. 100 volt. Next is the change in magnetic flux per unit ton if it has 200 tons. Now how much change in flux is taking place? Okay, so that you have to find. 200 tons are there. Okay, then you can use that EMF is equal to minus N d5 by dt from Faraday's law. So EMF is 100. And number of tons 200 d phi time is 0.02. So d phi equals to, so we'll use the magnitude here, so no need of putting sign. So then this can be 2, then d phi is equal to 0.02 by 2, 0.01. Okay, 0.01. So this is the correct option. Okay, next we'll go to the question 14. Solenoid of length 50 centimeter with 20 tons per centimeter and area of cross section 40 centimeter square completely surrounds another coaxial solenoid of same length, area of the cross section 25 centimeter square and 25 tons per centimeter. The mutual inductance of the system is this one. So you have to apply the formula of the mutual inductance of solenoid. So two coils are there. So which formula? So this formula you can use. So mutual inductance of two coils of total tons N1 and N2 is related to the length. Then if you put the values, you will get the answer. Okay, so value of mu naught is 4 pi into 10 to the power minus 7 into N1. Now N1 has 50 centimeter length and each centimeter has 20 tons. So 50 into 20. Okay, 50 into 20. N2 will be, length is same 50, but second coil has 25 tons per centimeter. So 50 into 25. And area 2. So second 25 centimeter square. So you have to change it. 100 into 100. Okay, so this is the question. So 25 tons per centimeter. So 25 into 50. First coil has 50 into 20, total number of tons, and area of the second coil is 25 centimeters. The mutual inductance can be calculated using this. So here length is 50 centimeters. So here I have not taken centimeter but meter. And here I have not changed the unit because we just need the total number of tons. So 50 centimeter, 20 tons per centimeter. So the centimeter cancel. So no need to change here 50 centimeter into meter because this is given per centimeter. That's why. But here length should be taken in meter because you need the actual length. And this is centimeter square, so you have converted. So if you solve it, then you will get 7.85 into 10 to the power minus 3 Henry. So this is the answer. Okay, then we'll go to the next question. A long straight current carrying wire passes normally through the center of a circular loop. If the current through the wire increases, there will be an induced EMF in the loop. Okay, there will be induced EMF in the loop. True or false? So it is like this. Like there is a loop and this is a wire, so perpendicular to the plane of the loop, and current is increasing here. Now as you know, current is increasing, that means magnetic field around this will also increase. So there may be magnetic induction, electromagnetic induction, but answer is false. So no magnetic induction, because uh, the magnetic field, suppose here, is perpendicular to this radius. Okay, so that means magnetic field is along the plane of the coil. So suppose this is the wire current, then magnetic field will be like this in this plane, so along the plane. So that means magnetic field is along the plane, so that means theta will be 90, so cos 90 is 0, that way you can say. Or if it is parallel, then no magnetic lines will cross or will pass through this surface, so that's why there will be no change in flux. Flux is there, but no flux is linked with the surface, so that's why no induction. So answer is false. Answer is false, because magnetic field are along the plane. Okay, like this. So no flux linkage. Okay, next question. Two similar circular coaxial loops carry equal current in the same direction. If the loops be brought near the current, nearer, the current in each coil will increase. So this is a question. Suppose this is one coil and this is another coil. Okay, so current is flowing in the same direction. Suppose it is flowing in the, if you observe from the side, it is flowing anti-clockwise. So here north pole will be there, and this side south pole will be there. Then when you bring them close, flux will change on each other. Then induced EMF will be there, and each one will oppose that one. Okay, so this is north pole iso. So here north pole will be induced, and here south pole will be induced. Here suppose this side north and this side south, which current is in this direction, so it is in the anti-clockwise direction. So here which pole will be induced? This side south, because it is current is flowing in the same direction. Okay, now when you bring them together close to each other, then obviously magnetic flux will change, then there will be electromagnetic induction, and this north pole will try to induce north here. Okay, and this north, that means it should have current in the anti-clockwise direction, so that's why they will cancel that, or the current will be reduced. So that's why the current will not increase, but current will decrease. Okay, so that's why it is false. Next question. The phase difference between the flux linked with the coil rotating in a uniform magnetic field and induced EMF produced in it is pi by 2, pi by 3, minus pi by 6 and pi. So you just remember that EMF is flux is related with cos theta, and EMF will depend on sin theta. Okay, you remember this. Flux depends on cos theta and EMF depends on sin theta. So when theta is 0, flux maximum, then theta is 0 when EMF will be minimum, and sin theta cos theta, so that you can take 90-degree difference. So pi by 2 is the answer. Next one, last question. Two coils have a mutual inductance 0.005 Henry. The current changes in the first coil according to the equation given, where I naught is 10 ampere and omega is 100 pi radian per second. The maximum value of EMF in the second coil is 2 pi, 5 pi, 6 pi or 12 pi. Okay, so this is again the question of mutual induction. Then we can use the formula E is equal to minus M di by dt and minus M. Now di, what is I given here? So I depends on time, you see, I naught on sine omega t. So you can put that expression I naught sine omega t. Then you have to differentiate it. Then minus M I naught sine omega t will be cos omega t into omega. Again you have to differentiate this function of a function. Then you are getting minus M I naught omega cos omega t. And maximum EMF will be cos omega, for cos omega t 1. Value of cos omega t 1 is the maximum. So then EMF will be M I naught omega. So magnitude is this one. So what is M? So all the values are given. 0.005. I naught 10 ampere and omega 100 pi. Then is 5 by 1000 into 1000 pi. Sorry, 1000 cancelled. So 5 pi. So 5 pi is the magnitude of EMF. So you can mark this one. Okay. So thank you for watching my video.